What if I told you that with just an Arduino and a PZEM-004T module, you can monitor the electricity consumption of almost any appliance in your home? In this video, we are going to put our smart energy meter to test by connecting a light bulb. On the LCD, you can see real-time measurement of voltage, current, power, energy consumptions, frequency, and power factor. After that, we will test the system with a refrigerator and observe how reading change under a high voltage. Finally, we will connect a high power electric iron and see how accurately the meter measure its power consumption. So let's get started. We will require the following components for this project: Arduino Uno, PZEM-004T module, 16x2 I2C LCD, breadboard, light bulb, and some jumper wires. Now let's take a close look of the PZEM-004T module, which is the heart of this smart energy meter project. This is the PZEM-004T energy monitoring module, which is used to measure various electric parameters in AC power system. The module can accurately monitor voltage, current, power, energy consumption, frequency, and power factor in real time. On the left side, we can see a CT sensor, which is used to measure current by clamping it around the live wire without making a direct electrical connection. The green screw terminal block is used to connect the AC main voltage for voltage sensing. The large yellow capacitor. The electrolytic capacitor helps to regulate and filter the power supply for stable operation. At the center of the board is the main energy metering IC, which processes all the measurement and calculate the electric parameters. The white optocoupler provides electrical isolation between the high voltage AC section and the low voltage communication circuit, ensuring safe operation. Finally, we have the UART communication interface, which allows the module to send data to microcontroller such as an Arduino, ESP32 or Raspberry Pi. To measure the electrical parameters, I first connect a CT sensor to the PZEM-004T module. Then I pass the live wire of the AC load through the center of the CT sensor. This allows the module to measure the current flowing through the wire without making a direct electrical connection. After that, I supplied the AC voltage to the module through its voltage input terminals. Once both the current transformer and AC voltage connection were made, the PZEM-004T was able to calculate and display important electrical parameters. Now connect the VCC pin of the PZEM-004T to 5V on the Arduino. Ground pin to ground pin. Connect the TX pin to digital pin 12 on the Arduino Uno. Connect the RX pin of the PZEM-004T to digital pin 13 of the Arduino Uno. Connect the VCC pin of the 16x2 I2C LCD with 5V, ground pin with ground. Connect the SDA pin with A4 and SCL pin with A5. Now we will install the required libraries. Now let's test the system. First, I pass the live wire through the CT sensor so that the PZEM can measure the current flowing through the load. Then I powered up the electric bulb, which acts as our AC load. And also turned on the Arduino Uno. As soon as the system starts running, the PZEM module began measuring the electrical parameters in real time. On the first screen, you can see the voltage, current, power and power factor being displayed. These values help us to understand how much electricity the load is consuming and how efficiently it is operating. On the second screen, you can see the total energy consumption in kilowatt hours and the AC frequency. The energy value keeps increasing over time as the load consumes powers, while the frequency indicates the frequency of the AC supply. This demonstrates that the system is successfully monitoring and displaying all the important electrical parameters in real time. Now let's test the system with a real household appliance, a refrigerator. Since refrigerator consumes more power than a simple light bulb and contains a compressor motor, it provides a better demonstration of the PZEM monitoring capabilities. Now let's test the system step by step. First, I powered up the Arduino Uno. As you can see on the LCD, it displays an PZEM error message. This happens because the PZEM-004T module has not yet been supplied with AC voltage, so it cannot read any electrical parameters. Next, I provide AC voltage to the module. As soon as the AC supply is connected, the bulb also turns on, indicating that power is flowing through the circuit. The error message disappears, and now you can see the voltage, current, power and power factor values being displayed on the screen in real time. To further test the system, I connect a refrigerator as the load. As soon as the refrigerator starts running, you can observe that current reading increases because the refrigerator requires more electric current than the bulb. Consequently, the power consumption also increases. At the same time, the power factor decreased slightly due to the inductive nature of the refrigerator compressor motor. This demonstrates how the PZEM module can accurately monitor play changes in electrical parameter for different types of loads in real time. Now let's test the system with electric iron. First, I apply the AC voltage to the PZEM module. And then power up the Arduino Uno. Once the system starts, the measured electrical parameter begin appearing on the LCD screen. At this point, the module is successfully monitoring the voltage and other electrical values in real time. Next, I switch on the electric iron. As soon as it starts heating, you can see the current reading increasing significantly. Because the iron draws a large amount of power, the power consumption also rises and reaches approximately 968 watts, indicating the high power requirement. Of the heating element. This shows that the system can accurately monitor high power household appliances. After a short period, you can see that current reading drops to 0 amps. This is because the electric iron has already reached its set temperature, causing its internal thermostat to automatically disconnect the heating element. As a result, the iron temporarily stops consuming power. This demonstrates the PZEM-004T module can track real-time changes in power consumption as appliances cycle on and off during normal operation. Now I switch off the electric iron while keeping the electric bulb turned on. As soon as the iron is turned off, you can see noticeable decrease in the current reading on the LCD because one of the major load has been removed from the circuit. The power consumption also drops significantly since the electric iron was drawing most of the power. The voltage reading may also change slightly depending on the load connection. At this point, the displayed values represent only the power being consumed by the electric bulb. This demonstrates that how the PZEM module can instantly detect changes in connected load and update the electric parameter in real time. With that, our PZEM-004T based AC energy monitoring system is working successfully. Throughout the demonstration, we tested the system with different household appliances, including an electric bulb, a refrigerator, and electric iron. We observed how the module accurately measured and displayed important electrical parameters such as voltage, current, power, energy consumption, frequency, and power factor in real time. We also saw how these values changed instantly as different loads were connected and disconnected. If you enjoyed this video, don't forget to like, share, and subscribe to the channel for more Arduino, ESP32, IoT, and electronics projects. Thanks for watching, and I will see you in the next project.